Thanks for watching my video lectures and showing interest in them. Today I would like to introduce the basic concepts and terminologies related to sample and sampling method or sampling design. As you all know that in psychology we study the human behavior and we want to make theories and principles related to human behavior. But often it is difficult to study all the human beings in a given population to make such theories, and thus we often make our study or conduct our study on a subset of the population, and based on the findings on those subset, we make inference about the characteristics of the population. This subset of population is called sample, and the method of selecting a subset of units from the population of the unit is called sampling. In this lecture, I will make or try to make clear or try to define these simple concepts related with sample and sampling technique. So let us first focus on the basic concepts related to sample and sampling technique. As I said, that a sample can be defined as a subset of units selected from a larger set of the same or similar type of units. For example, we can define that the students studying sampling techniques in psychology in a given university, say X. So this forms the population, and from that, if we select a subset of students, then that subset will be considered or defined as a sample. So this sample, that is the subset, provides data to compute the numerical descriptors of the sample. So we calculate the mean, median, or other numerical descriptors on the sample, and those numerical descriptors of the sample are called statistics. And based on those statistics, we try to make inference about the characteristics of the larger set, that is the population, and the characteristics of the population, the numerical descriptor of the population is called parameter. So, sample provides a convenient way to infer about the population characteristics, that is parameter, based on the sample characteristics, that is statistic. And sampling is basically concerned with method of selecting those subsets. So it is concerned with selection of the individual observations or the individual participants intended to yield some knowledge about the concerned population. And as I defined the terms parameter, when we are referring parameter or parameters, they refer to the numerical characteristics of the population. For example, mean of the population will be called population parameter. And the statistic is the corresponding characteristics, numerical characteristics of the sample. So sample mean, for example, is represented by X bar, and the population mean is represented by the Greek alphabet. So parameters are generally represented by Greek alphabets. Standard deviation, say for example, is represented by S for the sample, and the lowercase sigma is used for the population parameter, that is the population standard deviation. Now let us define what is population, because we, as I have defined sample, that sample is a subset of the population or the universe. So a population or universe is basically a theoretical aggregation of all the study elements, all the survey elements, and therefore it should not be confused with population of any country, any nation, or the population of the world, or population of any city like this. It is basically a theoretical aggregation, and the researcher defines the universe. So the researcher specifies the universe, and in the context of psychology, we can say that the general abstract mass of the people about whom we want to make inferences or draw conclusions by studying the sample is called population. So, population is a well defined larger set of units. For example, if I say all the students of Banaras Hindu University are population, I am defining that this is the students of the Banaras Hindu University. So in Banaras Hindu University, there may be some other people like employees, teachers, even the visitors may be there. But my definition of universe is that all the students of the Banaras Hindu University. So this will be the population, and then if we select few students out of the total number of students, then that subset will be called sample. So remember that it is defined by the researcher. So we can say that the group to which we wish to make the generalization of our findings of the sample, or about which we are making inference, may often be referred to as population. But remember that this population is a well defined set of elements, units, individuals, what you may call. But sometimes, even in well defined set of units, that is population, it is not always possible to have access of all the elements of the population. And thus, a distinction is often made about the theoretical population. Theoretical population consists of all the units about which we want to make generalization, and it may include both the accessible elements that can be accessed by the researcher as well as those who are not accessible. But the accessible population is that population, that larger set of units, which are only accessible if there is any unit or there is a subset of unit that is not accessible for drawing the sample, then that will not be the part of accessible population, but that can be part of the theoretical population. So we often do the sampling based on accessible population, but our goal is in general to draw inference about the theoretical population. Another distinction in two types of population is required. One is finite and another is infinite population. As it is very clear from the term itself, a finite population is that population whose members can easily be counted. For example, we can count the number of students of Banaras University by just taking all the nominal rod registers and counting them. But sometimes it is very difficult to count the entire units of the population. And if this is the case, then such population will be called infinite. And when it is likely that we are working with an infinite population, when the members of that population are not limited, they are unlimited. And therefore, we cannot count. For example, population of stars. Numerous stars, innumerable stars are there in the sky, and we cannot. Similarly, population of fish in the rivers. Practically, it is not possible because fish from one end of the river, because when we will be defining the population of the fish in any given river, say fish in river Ganges, so the number of fish in the whole river Ganges originating from Gangotri and ending in the Bay of Bengal will be ever changing, and it is really difficult to count all the fishes. They will be moving here and there, and then that will form an example of infinite population. Let us have some other term, as I discussed, that the actual method, technique that we use for selecting the subset of the elements from the well-defined larger set, that is the population, is called sampling. And this selection of the elements is done in such a way that we can make inference about the characteristics of the population on the basis of the subset. So if we are studying, say, 100 students out of the, say, 10,000 student population of the university, then those 100 students be selected in such a way that they can represent the 10,000 population of the students of that university. I will define representativeness very soon. And another term often used in the area of sampling is sampling frame. Sampling frame refers to the specific set of units, that is, the list of all the sampling elements of a given population will form what is called sampling frame. And this sampling frame I will discuss in other lecture and make distinction between various types of sampling. This sampling frame is required particularly in probability sampling. So sampling frame is the list of all the members of the accessible population. Those who are not accessible cannot be in the list. And examples may include, for example, suppose we are studying the population of Varanasi city, then the telephone directory of the whole Varanasi may provide a list of uh, telephone users. And suppose my population is defined as the telephone users of Varanasi, then the telephone directory will form the sampling frame. And then using some methods, for example, selecting every fifth telephone user taking from the directory, we can have a subset. Every 100 user from the same directory, there may be different techniques that I will discuss in other lecture. But in this lecture, my focus is just introducing. So sampling frame is the entire list of the set of units of the population. And another term we use in the area of sampling is sampling fraction. That is the percentage of the population that we have planned to select as a sample. So if we want to select 50% of the members of the population, then the sampling fraction will be 1 by 2 or zero point 0.5. And as I said, that one of the key skills, one of the key knowledge that is required for making a good sample, drawing a good sample, is that units in the sample should be drawn from the population using such tools, such techniques and designs, whereby the sample drawn must represent the population. So we may think of this representativeness as the reflection of the quality and characteristics of the population in the subset of the population. Very crude analogy I can give you that, for example, we are having the real Taj Mahal and then one miniature Taj Mahal that you will often notice they are sold by the local uh, shopkeepers, and they prepare a model of the Taj Mahal. If you will see that, it will be reflecting all the elements that are there in the Taj Mahal, something like that. So, if you have to define representativeness, so we can define it that this is the quality whereby a sample has the same distribution of characteristics as it exists in the population from which those sample units have been selected. So, representativeness is a skill of selecting a few elements, few units, few individuals in such a way that they reflect or represent the whole population. Another term that we often encounter when we study sampling, design and sampling technique is sampling reliability. And sampling reliability may be simply defined as the stability of the findings or results of the various samples. So, stability of the results across different samples of the same size and chosen from the same population is called sampling reliability. And we can use different methods to determine the sampling reliability. For example, we can make comparison of the various samples of the same size chosen from the same population. And if on the average the results are similar, almost close, we can say that there is a high sampling reliability. Another way is comparing the sample results with that of the universe or the population. And if the discrepancy is less, then it is highly reliable. And third technique may involve comparing the sample results with the subsamples drawn from the same sample. So we can do resampling from the same sample and then compare the results of the resampled samples with that of the sample results. Now, sampling design. You can guess that sampling design is simply the set of the procedures that we often use for selecting the units from the population. And this design involves such procedures so that the selected units may form a representative subset of the population. Now, when we do sampling, when we study sample and make inference about the population, different types of errors are inevitable. Some errors occur because of the deficiency or difficulty in drawing the sample itself, and some may be related to other features which are not related to the sampling, and therefore such errors are often called sampling and non-sampling. Sampling error. occurs when the result obtained from a sample is different from that of the population. Suppose population mu is 20 and the sample mean is 10. There is a difference of 10. And this error is assumed to be because of the error in the sampling method. We may assume that the sample has not been selected adequately and therefore the sample is less representative and this is resulting in the discrepancy. So sampling error is always the discrepancy in the findings of the sample and the population. So if the statistic, that is the sample characteristics, is not found to be the unbiased estimate of the population characteristics, that is parameter, then we can say that some sampling error is occurring. However, there are ways to determine the sampling error, and the most common simple way is computing the variance in the observed statistic of all possible samples that can be drawn from a finite given population of a given size. Suppose the population consists of 5 elements and we are drawing 3 elements as a subset sample from the 5, then all possible subset of 3 elements from the population of 5 and computing the statistic of all possible samples and determining their variance will tell the amount of sampling error. If there is no variation in the sample results, then there is no sampling error. However, this is almost unlikely. The finding of one sample will differ from the finding of the other. On the average, the dispersion across the all possible samples will be the variance in the statistics, and that variance, that is the square of the standard deviation of the all possible statistics, will represent the sampling. So, in simpler terms, we can say that sampling error refers to the fluctuations of the findings from one sample to the other sample. Such sampling errors may be systematic or biased errors, errors that are resulting due to some known biases in the sampling method or sampling procedure, and there are some chance errors, random errors, and that are also called unbiased errors. So, the chance difference between those who have been included in the sample and those who cannot be included may also be a source of error, and that random sources of errors are called random errors or unbiased errors. On the other hand, non-sampling errors are those which are resulting from the inaccuracy and bias of the measurement and other data collection procedures used for studying the sample. So non-sampling errors are not related with the method or representativeness of the sample. It is related with the tools and measurement tools and devices used for studying the sample, collecting data from the sample. Now I will discuss two important theories on which the sampling design and sampling techniques are based. And related to those two theories are two critical questions that the researchers should often ask while doing sampling. The first theory or law, there are two laws that forms the base of sampling. The first law is called the law of statistical regularity. It is a notion in statistics that random events, when repeated enough number of times, they often exhibit a regularity, stability in the file. For example, if we throw a dice once, it is difficult to predict what will be the result, what will be the outcome. But we throw the dice several times, then if as the number will increase, a point will come where the probability of the outcome or a given outcome will, say, coming six out of the total possible events will become stable, fixed. For example, if we are tossing a coin, it can turn either head or tail. But after a number of trials, we will notice that most often it is coming head, or 50% times it is coming head, and 50% time it is coming tail. So, as this law of regularity says, that if we are studying random events, if the events are random in nature, and when that random events or experiments are repeated several times, enough number of times, then the results show a regularity. And this law states, or in other words, we can say that this law states that elements in terms of sampling chosen at random from a large group, that is population, are almost sure on the average to possess the characteristics of the population. So, according to the statistical law of regularity, if we are two things are required. First, the selection should be random, the sample should be selected randomly, and the size should be large. If we are having a random selection method and the size is large, that is, that randomness is occurring enough number of times, then this law says that it will show some regularity, and that regularity is that the characteristics that is in the population will be reflected or represented in the sample. As a corollary to the above law is another law which is called the law of inertia of large numbers. It states that if other things being equal, the larger the size of the sample, the more accurate will be the results. And this likelihood of greater accuracy because of the larger sample size is based on the fact that if the sample is being selected randomly and it is in large size, then the chances are very high that both positive and negative random errors will occur almost equally, and therefore they will cancel out each other, and it will have no significant effect on the overall characteristics of the selected sample. Now, the two critical questions that we often ask and we should ask in the sampling, the first is that is the sample indeed representative of the population or there are biases? If the answer is that yes, it is representative, then we have achieved the main goal of the sampling, as I discussed earlier, that sampling involves selecting subset of units in such a way that those subsets are representative of the population. But if the subset selected is not representative, it is somehow biased, then the actual goal of the sampling has not been achieved. But in real life, we lie in between. So we may have some degree of representativeness and some biases are also likely. And the second critical question is, and this depends on the biases or representativeness, depends on the method used. If we are using probability sampling design, then it is very likely that we will arrive at a more representative sample. But if we are using non-probability sampling, then it is very likely that we will be suffering from some biases in the sample selection. And the second question that we should ask is, are there enough persons in the sample, that is the size of the sample is enough large to ensure that the sample can be considered representative of the population. So it is basically related to the laws that I stated. So we have to take care while doing sampling the two aspects presented in the form of two critical questions. The first is that as far as possible, the sample should be representative, and as far as possible, we should go for a larger sample size. And as this sample size will be larger, it is very likely to be representative and more accurate. Now, apart from representativeness, there are some other characteristics that are essential or required for a sample. But among all the characteristics, representativeness is the topmost. And I would again define that a representative sample is one in which the characteristic of the population is distributed in the same proportion as it exists in the population. So representativeness is ensured by using the method of random selection. As you will recall from the previous slide, that two laws, the law of statistical regularity and the law of inertia of large numbers. And these suggest that if we will select the elements randomly and if the size will be large, it is more likely, it is almost sure that we will arrive at the representative sample. The second characteristic is adequacy of the sample size. The sample size must be adequate so that it can represent the population. Suppose the population is of 10,000 students, and if I am selecting one or two students, it is very less likely that those one or two students will represent the population. But suppose I am selecting, say, 1,000, 2,000, it is more likely that that sample will represent the population. Third is independence. The representative sample can be obtained only if the selection of the units shows this feature, that is independence, and there are two essential features. First, the selection of an element in the sample is not dependent on the selection of the previous element. So if element A has been selected, it is not going to influence the selection of any of the other remaining elements. Then this independence characteristics has been achieved. If it is not the case, then it is very likely that we will not arrive at a representative sample. Similarly, if independence is there, then each member has an equal or fair chance of selection in the sample. So the selection of one unit is not going to influence the selection of the other unit, and each element or unit of the population has equal or fair chance of selection. If these two features, two things are achieved, then we can say that the essential characteristics of independence of selecting units is there. And homogeneity is another important feature or characteristics of a good sample. It refers to the fact that nature of the units or element in the sample is or should be same as in the population. So if the units in the sample are essentially of the same nature as it is in the population, then we will arrive at a sample of homogeneous units. So all the units sample will be of same or similar to each other. More the homogeneity, more accurate will be the results. Now, as I said earlier, that we often do not study the whole population because studying whole population is not very convenient method. But you may say that, sir, since population is defined by the researcher and we can define a small population that can easily be studied. For example, if I say that five or the students sitting on the first bench. So this in any classroom, students sitting on the first bench will be fewer in numbers, and we can study all those students if that is the population. So if we are studying each and every element of the population, then that method is called census method. And this is another way of studying the population characteristics. But remember that we do study the sample and not prefer the census method for knowing about the population. We study the sample and infer or draw conclusions to develop knowledge about the population. So, census method may be defined as studying each and every elements of the population. But it may appear that if we are studying each and every element of the population, then the question of representativeness is no space here. But despite this representativeness in this census method, there are different limitations that limits us, that precludes us to use this census method in the actual real studies. First, if we are going for census, it will require more effort, time, money for its conduction. Second, if the target population is very large, say even if we are going to study the India and China, the population is very large. And study involves such variables that can change after certain time. Say we are studying the infants who are born in India and China, and the population is so huge that when we will start studying the infants, it will take so much time that the infants that we initially sampled for our study will not remain infant when we will reach to them for actual study. So this method in this condition cannot be used or will be difficult to use, and if used it will not provide accurate results. Similarly, it can also not be used if the population is infinite, because infinite populations means the there are so many elements that we cannot count, we cannot access each and every element. So the census method is not possible. And there are some study techniques that may involve destroying the elements of the study. For example, many studies done on animal model, say on rats, after doing a study because of ethical requirements, the study animals are often sacrificed. If for drawing a better conclusion, we say that we will study the whole population of the rats over the globe, then it is practically not good. It is not possible also because then there will remains. For example, I am testing the durability of the bulbs produced in a factory, and I have sampled all the bulbs, and I am just throwing that at what height the bulbs are not able to uh, or the bulbs crack, and then what will happen that ultimately I will break all the bulbs of that factory, and there will be no. So under this condition, we cannot study all elements, and the census method is not possible. Finally, against the census method, if we are going to use sampling method, they have several advantages. First is the increased accuracy because we are not studying the entire population. We are studying a small number of units from the population. This will reduce the effort, time, volume of work. And as a result, what will happen? That we can very carefully, intensively study each unit of the sample. And this will result in more accurate measurements, more accurate findings. Similarly, if the sample size is small, we can recruit trained professionals. And if trained professionals are doing a study and collecting data, then again this will reduce the non-sampling errors and the findings accuracy will improve. So increased accuracy is one advantage of sampling method. It is economical, so it will reduce the cost in terms of money and time both. And since we are studying a smaller number of individuals, that is a sample subset of the population, the data collection speed will also be high. We will complete the study more quickly compared to census method. Further, because of the smaller size of the sample, more detailed information can be collected about each element of the sample, and therefore we can arrive at better findings. And as I said while discussing census method, that in some situation the sampling may be the only method of data collection. For example, if the study technique involves destroying the sampled units, then we will have to do sampling only. We cannot go for the census method. Despite all these advantages, there are certain limitations too of the sampling method. If the sample is biased and it is likely and it depends on what technique we are using, then under that condition, the findings of the sample will not be unbiased estimate of the population and it will not represent the population characteristics. And thus, the chances are very high that the obtained findings on the sample will be less accurate or inaccurate. Another limitation is that selection of an unbiased and representative samples requires the services of experts. For example, here in India, there is one organization of the government of India called NSSO, National Sampling Survey Organization. They are team of statisticians having expertise in sampling design and sampling techniques, and they are doing various types of census study uh, for the government of India. So, sampling if it has to be done with greater accuracy, if it has to be unbiased, it will require often the services of the experts. So these are limitations. And now, finally, with this slide, I will conclude that we have now studied that what is sampling? It is drawing a subset of units from the larger set of units. It is called population. And for the method that we use is called sampling. And for doing sampling, we follow some predefined steps. So first thing that is required is that we must have the knowledge of the population. We have to define what is the population, what is the universe. If we have defined the universe, then only we can proceed for the other steps of trying sample. If we are going for the probability sampling methods that I will discuss in another lecture in details, then this second step is also required, that is specification of the sampling frame. That is, we must have the list of the members or units of the population. But for non-sampling, non-probability sampling, this step may be skipped. And after this, we must specify the sampling method. That is, finalizing the sampling design is the next step. So what method we are going to use for drawing the sample so that our sample is more representative is the next step. And once we have decided the sampling plan, the sampling design, then what will be the sampling fraction? What will be the size of the sample? That has to be determined. And there are various techniques. It depends on what statistics we are going to use on the sample. If we are going to use multivariate statistics, we will require larger sample size. If we are going for non-parametric statistics, we may work with smaller sample size. So there are many things that will help us to determine the sample of size of the sample. But before doing sampling, we must determine the size of the sample. And once we have finalized all these four steps, then the last step is just following the sampling design and drawing the actual sample units. That is implementation of the sampling plan. Now, there are many factors that can influence the sampling decisions, for example, size of the population, the methods to be used. These are the sampling decisions that I have just discussed. And there are many factors that can influence. In this slide and the next slide, I will discuss those factors. The first is the size of the population itself. If the population is very large, then in that condition, the first thing is that we have to go for the sampling method, and census is not the recommended method. And since the universe of the population is large, to have a representative sample, the size of the sample should be larger. So larger the universe, larger will be the sample size. So sample size of the is determined by the size of the population. If the population size is small, we can work with a smaller sample size. Similarly, apart from size of the sample, the sampling method is also dependent on the size of the population. For example, if size of the universe is very large, some forms of sampling method may be more easy, convenient compared to others. For example, multi-stage or cluster sampling or a systematic sampling is more convenient than drawing a simple random or a stratified random sample from a very large population. The latter two, that is this simple random and stratified random sample, will be more costly, more time taking. Another factor that we may consider that can influence the sampling decision is cost involved in obtaining the evidence. So the sample size, what will be the sample size? Apart from other things, it also depends on how much cost will be involved in obtaining one sample unit or the desired sample size. If the cost involved is low and we are having sufficient resources, then we can go for more time taking costly methods, but at the same time more accurate methods of sampling. For example, simple random sampling, stratified random sampling. But if we have fewer resources, then we are bound to go with less costly, but at the same time low accurate sampling methods like snowball sampling and other non-probability sampling methods. And here we should remember that the lower cost has some hidden other cost. For example, if we are going for low cost sampling method, so it is not, it is involving some hidden cost like lower accuracy. The more biased samples are likely, and therefore the results will also be less accurate. Similarly, convenience and accessibility of elements is another factor that often influence the sampling decision. So, for example, sometimes the study variables involved are such that it is difficult to get individuals suitable for the study. Or sometimes individuals with that variables may be rare in the number. For example, if we are studying, say, HIV or AIDS, getting a suitable number of individuals may be really very difficult. And suppose we are studying some very rare disease or rare conditions, then under that condition, the entire population will be restricted. So such situation adversely affect the sampling decision. And in this condition, we are often bound to sample only those participants, those units which are really accessible. And because of this, since we are, for example, there was a time when there were only 12 individuals having commissurotomy. Whose commissural fibers were surgically bisected. And those commissurotomized patients were 12 in number. And so, if anyone was doing a study on such patients, they were bound to study only those 12. And those 12 may not represent the entire case or they may not be the representative. Similarly, if the elements are not available or accessible in some situation, then one cannot decide for a probability sampling design. And then we will be using the more biased non-probability sampling methods. So, which methods we will be using? It depends on the convenience and accessibility of the elements. Similarly, homogeneity versus heterogeneity of the population is another factor. If the population consists of units which are very homogeneous, then we can go for a very small sample because that will form a representative sample. But if the elements in the population are very heterogeneous in the nature, then we will have to go for a larger sample, or we will have to follow a stratified random sample so that the heterogeneity can be well captured and we arrive at a more representative sample. There are other factors that you can see. Similarly, the desired degree of precision and accuracy. If we are interested in more precision, more accuracy, then we should go for larger samples. Similarly, what method of sampling we are using? If we are using simple random sample, then a large sample will be required. But if we are going for a stratified random sample, a small sample size may also give a representative sample. So size of the sample also depends on the sampling method. Similarly, the nature of the study also influences the sample size decision. If we are going to conduct longitudinal studies and say for several years, then it is not affordable to have a very large sample size. But if we are doing a cross-sectional study, then we can go for the larger sample size. Similarly, if we are having a large number of restrictions, that is inclusion and exclusion criteria for defining the population, then under that condition, the selection using random selection procedure becomes difficult, and then we go for a judgmental or purposive sampling. And being a non-probability sampling technique, this judgmental or purposive sampling often leads to a biased sample and therefore less accurate results. And finally, the nature of the respondents, the participants, the individuals, it also influences the sampling decision. If we are dealing with such respondents who are likely to be less cooperative in taking part in the study, then we will have to take a larger sample because the dropout rate will be higher. But if we are working with such respondents who are likely to cooperate and almost all are ready to answer, then we can go for a smaller sample size. So thank you very much. These are some of the basic things that I thought would be helpful for you for understanding what is sample, sampling technique, sampling design, and what are its theoretical rational base, advantages, disadvantages, etc. In the next video lecture, I will cover the probability sampling techniques. Thank you very much.